Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at multiplying and dividing complex numbers. So let's first look at multiplying. So just as when we do any algebra, if no operation is written, it's always times. So how would we multiply together these two complex numbers? Well, all we do is use expansion of brackets. We use FOIL. So remember when we're using FOIL, the idea is we have to multiply everything in the first bracket by everything in the second bracket. So I have to multiply A by C, and then I have to multiply A by ID. Similarly, I have to multiply IB by C. Now, when I multiply IB and ID together, I've got B times D, but we've got I times I, which is -1. So this becomes a negative. Because I times I squared is -1, so it's -1 times BD. And then you can just collect the components. We collect the two real components, AC minus BD, and then we collect the two imaginary components, AD and BC. How easy is that? So let's look at an example with numbers. So let's say I want to multiply 3i plus 2 by 5 minus 4i. So all we do is use our expansion of brackets. 3i times 5, 3i times minus 4i, so 3 times 4, -4 is -12, I times I is -1, so that's going to give me +12. 2 times 5 is 10, 2 times -4a is -8i. So we just collect the real parts. 12 plus 10 is 22. The imaginary parts, 15i minus 8i is 7i. And we're done. All right, let's now look at dividing. So in order to divide one complex number by another, we need to know about complex conjugate. So the complex conjugate of a plus ib is a minus ib. So it's like the same thing, same values of a and b, but a different sign between them. So to divide by a complex number, we multiply by its complex conjugate. Doing something like this is very, very tough. But if we multiply top and bottom by the complex conjugate, we will be multiplying by 1. So the complex conjugate of 2 minus I, it's the same numbers, but instead of having a minus, we have a plus. We have the opposite sign between them. So what I do now is multiply the tops together and multiply the bottoms together. See, this number here in black is being multiplied by 1, so we're not changing its value. So let's multiply it together, the tops. So 4 times 2, 4 times I, 3i times 2, and 3i times I gives a -3. On the bottom, we can use our difference of 2 squares. 2 times 2, 2 squared is 4. I times I squared is -1, and we stick a minus between them. So what we're left with on the top, 8 minus 3, 4i plus 6i, and then 4 subtract -1 is 5. So we can further simplify this. 5 divided 5 is 1. 10i divided by 5 is 2i. So sometimes you won't be able to simplify this number, and it's really important that you note that we can only simplify if both terms have the same common factor. For example, if I had something like 6 plus 7i on 3, I can't simplify that, because even though 6 and 3 have a common factor of 3, these two don't have a common factor of 3. So this one cannot be simplified. 1 plus 2i is the answer. So essentially we want division, as always, to undo multiplication. If you multiply this and this together, you get this. Now this number is a lot easier to work with. See, the thing is, when you multiply two complex conjugates together, you always get a real answer. This is very, very similar to the process we used when we were rationalizing the denominator of surds. When you multiplied a surd by its conjugate, you got a rational number. Here, when you multiply a complex number by its conjugate, you get a real number. And it's much easier to visualize dividing a number by 5, then dividing a number by 2 minus I. So that's why this process works. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.